Congratulations, guys. You're on the last podcast for the worksheets, if you're actually watching these, if you need them. I will mention that I'm not going to go and actually write the names out. It's just going to take too long. So I'll abbreviate some things, but I will go through the logic that I'm using to figure out how to name something. So let's look at some of these and identify them first. I notice this is a metal. That tells me this is going to be ionic. This one's starting with hydrogen. That tells me it is going to be an acid. Arsenic, I'm not terribly sure because arsenic can be a couple of things because it's one of those where you think it's a metal but you're not sure. But you'll notice that this is a PO3, so that's a phosphite, so we're going to treat that as ionic. Boron is definitely not ionic, so that's covalent. And bromine is not metallic. Boron and bromine are not metallic, so they're going to be covalent. All right, let's go and name these. This is silver, Ag, and CrO4 is chromate. And silver always takes on a +1 charge, so I don't need to worry about looking for which version of silver it is. So this is simply silver chromate. Right. This one, I'm going to take a little bit more time with you. You have to go back and look at your acid rules. Remember that CO3 is carbonate, which means this is an ic acid. So this is carbonic acid. How about your next one? This is arsenic. Which arsenic is it? Well, what kind of charge would it have? Well, if we do the reverse crisscross method, right, you should be able to see that you're going to have an arsenic with a +5 charge, and you're going to have a phosphate with a 3- charge. Excuse me, a phosphite. Does it make sense that phosphite would take on a 3- charge? It does. So this would be arsenic. And you do have to put this thing in parentheses, and it does need to be there. Arsenic 5, phosphite. Not phosphate, but phosphite. Now these last two are covalent, which means they're really easy to name. I have boron, which is the first thing, boron. And the second one is tri, because they're 3 fluorides. And my last one is going to be bromine. Notice I only have one boron and I only have one bromine, so I don't put a prefix in front of that. And 5 is penta, like pentagon, pentachloride. All right, we have 46 of these to do. I'm not going to write them all, but I wanted to give you just a start on how we were doing it. All right. Number 6 is a hydrate, which means I need to name it ionically. Carbon is a non-metal, so that's covalent. Chromium is a metal, so that's ionic. This is a hydrate. Ooh, interesting. The little dot things aren't showing up in here. They should be. I'm sorry. So this is a hydrate, but when you name it ionically to start. And copper is a metal, so it's ionic. So let's go and do this. Your first one, and by the way, guys, I'm doing these live, so if I make a mistake, I'm not using notes, so I'm just doing them live. So this is calcium. NO3 is nitrate. So this is calcium nitrate dihydrate. Calcium nitrate dihydrate. Number 7 is covalent, so it's simply carbon, and there's one oxygen. It's not carbon oxide, it's carbon monoxide. You'll always have to put a prefix before the second word. All right, chromium. When I do my reverse crisscross, this is 3+, and that's 2-. Does oxygen take on a 2-? It does. So chromium is a 3+. So this is chromium 3, and the 3 has to be there. Chromium 3 oxide. How about your next one? Well, your first thing is cesium, and CO2 is carbonite. So this is cesium carbonite dihydrate. And, well, wait a minute, you didn't put anything in parentheses. Well, you don't need to, because cesium, if you look at the periodic table, cesium is in column 1, so it's an alkali metal, so it always takes on a +1 charge. All right, copper, on the other hand, is not like that. So, where is my cursor? I lost my cursor. There you go. John, you guys can see it. I can't. Okay. So, this is copper, and that should have a 2+ charge. And phosphorus should have a 3- because I'm doing my crisscross. I'm taking these numbers up and crisscrossing them. All right. So does phosphite, PO3, take on a -3 charge, it does. So copper is going to take on a +2. So this is copper 2 phosphite. Not phosphate, but phosphite. Okay. Let's keep working our way down. Number 11 is clearly an acid because it starts with an H. 12 starts with silver, so that's metallic, so that's ionic. Chromium is metallic, so it's ionic. Number 14 is again an acid because it starts with an H. And selenium is right below sulfur on the periodic table, so it is going to be covalent. All right, so let's look at our first one. CO2. Well, CO3 is carbonate. So this is carbonite. This is hydrogen carbonite. So carbonite means we have an OUS acid. So this is carbonous acid. Carbonous acid. How about this one? This is silver, and that's sulfite. So that's all I need to know. It is silver sulfite. It's ionic. Chromium oxide. Yes, it is chromium oxide, but which chromium are we using? Remember, chromium is a transition metal, and it takes on multiple charges. Well, if oxygen has a 2- charge, that means chromium must have a 2+ charge. So this is chromium 2 oxide. How about this guy? Cr2O7. You have to look that one up. Right? That is dichromate. Cr04 is chromate, but Cr2O7 is dichromate. So because you have an H in front of it, it's an acid, and an 8 is an ic acid. So this is, OMIC, dichromic acid. All right. And finally, my last one, which is real easy, this is selenium and chlorine, so it's selenium dichloride. All right. Let's look at this. This is gold, so it's a metal, so it's ionic. H, that's an acid. Notice this is a hydrate. So I'll name the beginning of it ionically. H2, that is an acid. And Mn, that is a metal, so this is ionic. So let's go ahead and do this. This is gold sulfate up at the top. I believe this year what we're doing is we're saying that gold, I'm not sure if gold can take on multiple charges, but if it can, then it would be gold 1. Otherwise, it would just be gold. I don't remember. But it's either gold or gold 1 sulfate. H2S. Well, this is sulfide. It's on the periodic table. So this is going to be hydrosulfuric acid. You have to go back to your rules to make sure you understand your rules. Your rules say that if the anion ends in IDE, which in this case it does, this is sulfide, then it is a hydroic acid. All right, let's look at number 18. This is going to be copper sulfite. Which copper is it? Well, we do our crisscross method, and there's one of these. This is a +1, and this is a -2. Does it make sense? Sulfite takes on a -2 charge. It does. So this is going to be copper 1 sulfite trihydrate. Copper 1 sulfite trihydrate. How about number 19? Right. Well, we're looking at SO3. SO3 is an ite. This is sulfite. SO4 is sulfate. SO3 is sulfite. So that means this is going to be an OUS acid. So this is sulfurous acid. Sulfurous acid. All right. How about this one? Well, this tells me, if I do my crisscross method, that this should have a 2+ charge, that this should have a 1- charge. And if I look up bisulfate, it does in fact have a 1- charge. So manganese is going to have a +2 charge. So this is manganese 2 bisulfate. Not just sulfate, but bisulfate. The bisulfate refers to the H, SO4. Right. Number 21 is covalent. Number 22 is ionic. Number 23 and 24 are hydrates, which means we'll look at them ionically. And number 25 is also ionic because manganese is a metal. Alright, so my first one is krypton. Krypton difluoride. Remember, you need a prefix before your second word. Krypton difluoride. Number 22 is simply lithium chloride. And number 23 is simply lithium nitrate, because lithium is on the periodic table, so it's simply lithium nitrate, and the 3 means tri, so it's lithium nitrate trihydrate. Number 24 is simply magnesium sulfate. Again, magnesium is in column 2. Magnesium sulfate, and the 7 means hepta, so it's heptahydrate. And number 25 is manganese borate, but now this is something that is in, it's a transition metal, so I have to look and say, well, that's a 3- charge. That means this must be a 3+ charge, because I have to balance, because I've got one of each one. So this is manganese 3 borate. All right, number 26, that's an acid. Number 27, nitrogen is not a metal, so it's covalent. Number 28 is a hydrate, and we name it ionically. Number 29 is an acid. And number 30, again, is a hydrate. We name it ionically. Okay. Again, I'm sorry that those dots aren't there. All right, so your first one is an acid. So I look at the SO4, and that is an 8. That's sulfate. So this is sulfuric acid. And number 27 is covalent. So I have to use my prefixes. So it's dinitrogen. And the 5 is pentasulfide. So dinitrogen pentasulfide. Right. Number 28, this part is simply sodium sulfate. That's easy. And 10 is deca. So this is decahydrate. Sodium sulfate decahydrate. And number 29. This is an acid. This is borate. BO3 is borate. So this would be boric acid. Boric acid. And number 30, again, we name it ionically, so this is going to be sodium phosphite. Remember, phosphate is PO4, so this is PO3, so it's sodium phosphite. And 4 is tetra, so it's tetrahydrate, so it's sodium phosphite tetrahydrate. All right, how about this one? Well, sulfur is definitely not a metal, so that's going to be covalent. And 23 is going to be ionic, because sodium is a metal. And 33 is going to be an acid, because the hydrogen. And 34 is going to be covalent, and 35 is also going to be an acid. So let's look what happens when we have 31, which is covalent. We have 1 sulfur, and we have 4 chlorines, so it's sulfur tetrachloride. And 32 is actually a lot simpler than it looks. Here's sodium, and this big long thing out here. That big long thing is acetate, C2H3O2. So this is simply sodium acetate. Very simple. PO4 is phosphate. So this is going to be, the rule says if it's phosphate, it's an ic acid. So this is going to be phosphoric acid, H3PO4. 34 is covalent. So we take the first name, which is xenon. We use a prefix, which is hexa. And then we use this, which has an "ide" at the end. So it's xenon hexa fluoride. And number 35 is an acid. So this is IO, if I think about it, it's on the periodic table. So it's iodine, which makes it iodide. And iodide, IDE, says that it is going to be a hydroic acid. This is one of those that's really strange. This is hydroidoic acid. Right? Different people pronounce it different ways, but you get the concept. All right. Number 36 is definitely a hydrate, because we see it's multiplied by water, and we see 38 is a hydrate also. So again, we name those ionically. PF3 is covalent, because phosphorus is a non-metal. And nickel is a metal, so that's going to be ionic. And number 40 is going to be an acid. All right, so let's do these. This is sodium. Number 36 is sodium, and this is chlorate. ClO3 is chlorate. So it's sodium chlorate, and because there's only one water, it is monohydrate. So sodium chlorate monohydrate. This is only one. All right. This one's easy. 37 is phosphorus trifluoride. This is nickel nitrate, but notice that there's a 2 down here, which means that nickel has a 2+ charge and nitrate has a 1-. Makes sense that nitrate has a 1-, so this must be nickel 2 nitrate, and then the 6 stands for hexa, so it's hexahydrate. So it's nickel 2 nitrate hexahydrate. This one is going to be a 3+ charge. This is going to be a 2+ charge, and carbonate does take on a 2+ charge. So this is going to be nickel 3 carbonate, because nickel has a 3+ charge. And your last one on this page is hydrogen with phosphorus, and remember that would be phosphide because it's on the periodic table. So this would be hydrogen phosphide. So IDE tells you it is hydrophosphoric acid. Because it is an acid, but it's hydrophosphoric because this is an ide. All right, 6 more to go. Your first one is nickel carbonate. The question is, which nickel is it? Well, carbonate has a 2- charge, which means nickel has to have a 2+ charge. So this is nickel 2 carbonate. Chlorine has a -1 charge, but lead must have a 4+ charge to counteract it because of this 4. So this is going to be lead 4 chloride. Those are both ionic. Your next one is covalent, and your bottom one's covalent because they both start with non-metals. And because 44 starts with H, it is an acid. So PF5 is simply phosphorus with 5 fluorine, so it's phosphorus. And the 5 is pentafluoride. Number 44, we are looking at PO3. PO3 is phosphite. Phosphite tells you that this is an OUS acid. So this would be phosphorus acid. And finally, number 45, this is sulfur, and this is 3 oxygens, so it's sulfur trioxide. And here's your last one. Again, doesn't happen frequently because it has to go and be under a lot of heat and pressure. But this is xenon, and because xenon is a non-metal, this is covalent, so it's going to be xenon trioxide. Okay? That's it. Questions? See me in class. Hopefully I didn't mess up. And have a wonderful day. We'll see you later. And congratulations for finishing. Right, bye-bye.